Equipped with a leveling rod and an instrument, we can measure elevation differences. In this video, we'll explore the basic field processes involved in measuring those differences and then computing elevations. I'm Todd Horton for the Illinois Professional Land Surveyors Association.
Using an optical level, we create a horizontal line of sight. Where our line of sight intersects the level rod, we take rod readings. With these rod readings, we can compute elevation differences. With practice, most instrument operators can confidently read the rod when it is 250 feet away. Thus, if I need to find the rise between two locations 500 feet apart, I simply set up halfway between the points and take two readings. But what if I can't see between those points? For instance, in this scenario, the elevation difference is greater than the height of my tripod. Or what if the locations are 5,000 feet apart? Well, to overcome these obstacles, we perform a level circuit. We perform a level circuit by measuring a series of elevation differences end to end. In the first video, we illustrated the concept with the Carpenter level, but now we do the same process on a grander scale with an optical level. To find an unknown elevation shown here on the right, we must first start from an elevation that is known, shown here on the left. An elevation is a vertical distance above or below a reference surface. We commonly use mean sea level as a reference surface. For instance, the summit of Mount Everest is 29,029 feet above mean sea level, and the lowest point in the United States is Death Valley at 282 feet below sea level. By measuring vast networks of level circuits across the continent, surveyors have established heights above sea level at stable, permanent benchmarks. Benchmarks come in many forms and are attached to everyday objects like bridges and fire hydrants. Let's walk through a typical level circuit we call benchmark leveling. You may hear this process called differential leveling or control leveling as well. Here, our survey site is 1/2 mile from the nearest benchmark across a shallow valley. We need to determine the elevation of a newly constructed benchmark on the site. Because of the terrain and the distance involved, we'll have to set up the instrument multiple times to measure a series of elevation differences. First, we'll set up our instrument where we can see the rod sitting atop the known benchmark. Our first rod reading is 4.69 feet. Since this reading is taken on a point of known elevation, we call it a backsight, commonly abbreviated as BS. With this first backsight reading and the known elevation of the benchmark, in our case 842.17 feet, we can say the instrument line of height is 4.69 feet above the elevation of 842.17. Thus, the HI of the instrument, commonly abbreviated as HI, is 842.17 feet plus 4.69 feet, which equals 848.86 feet. When the backsight reading is complete, the rod person can move beyond the instrument operator toward the survey site. At a convenient location where the instrument is visible, the rod person will create a turning point. A turning point is a temporary intermediate point in a level circuit that we use like a benchmark. Each turning point must be stable and have a distinct peak or high point on which the rod will rest. Here, the rod person is using a cold chisel driven firmly in the ground. When it is stable, its top can have only one elevation. This concrete curb has high spots that make good turning points. And this sidewalk corner will work too. With the rod person holding the level rod atop turning point 1, labeled here as TP1, the instrument operator can make another rod reading called a foresight, commonly abbreviated as FS. A foresight is a rod reading taken on a point of unknown elevation. We don't yet know the elevation of turning point 1, so the first reading there is a foresight. Our foresight reading at turning point 1 is 6.08 feet. Since we know the HI is 848.86 feet, and since the instrument line of sight is 6.08 feet above turning point 1, we can now compute the elevation there. We'll subtract the foresight reading from the height of instrument. 848.86 feet minus 6.08 feet equals 840.78 feet. Now we know the elevation of turning point 1. Next, in order to extend our circuit toward the new benchmark, the rod person will stay put while the instrument operator moves beyond turning point 1. At a new location where the rod is clearly visible, the instrument operator will set up the instrument and take a new reading on the rod at turning point 1. Now, here's an important question. Will this reading be a backsight or will it be a foresight? Remember, a backsight reading is a reading on a point of known elevation, and a foresight is a reading on a point of unknown elevation. So, which is it in this case? Well, turning point 1 has a known elevation based on our first instrument setup. So with a backsight reading of 2.95 feet, the instrument has a new HI. That is, the line of sight is 2.95 feet above the turning point 1 elevation of 840.78 feet, giving an HI of 843.73 feet. Now, the rod person can leave turning point 1. Turning points are for short-term temporary use. After reading both a foresight and a backsight on his cold chisel turning point, he can remove it and move beyond the instrument to set a turning point at a convenient location. With a foresight of 7.17 feet, the elevation on turning point 2 will be 836.56 feet. Well, what should happen next? Simple. The process repeats. At each new instrument setup, there will be a new backsight reading and the new HI. At each new instrument setup, the operator will take two readings, a backsight and a foresight. At each turning point, the rod person will hold the rod on the point for two readings, first a foresight and second a backsight. In the field, the rod person and the instrument operator move separately, taking turns and moving forward in a leapfrog pattern. With the final foresight, there are finally enough measurements with which to compute the elevation of the new benchmark. The process is fairly simple, repetitive, and efficient.
So far, you've seen the core concepts. In the next video, I'll show you how to prevent mistakes, how to record your readings, and how to compute with confidence. I'm Todd Horton for the Illinois Professional Land Surveyors Association.